MS Ramaya University of Applied Sciences.
Hi students, let us have a discussion on load test on DC shunt motor. The objectives of this laboratory experiment are to conduct a load test on the DC shunt machine to draw the performance curves. Introduction. DC motor is a device which converts electrical energy into mechanical energy. Construction of DC motor is very similar to a DC generator. The DC machine can operate both as a generator and a motor. When the DC machine operates as a motor, the input to the machine is electrical power and the output is mechanical power. DC motors can provide a wide range of accurate speed and torque control. Types of DC motors. DC machines are mainly classified into two types. They are named as self-excited and separately excited DC machines based on the field winding connection. In case of self-excited DC machine, field winding is connected to the DC machine itself, whereas in the case of separately excited DC machine, field winding is connected separately. Self-excited DC machines are further classified into three types. They are shunt machine, in which the field winding is connected in parallel with the armature. Series machine, in which the field winding is connected in series with the armature. Compound machine, in which some part of the field winding is connected in series with the armature and some part is connected in parallel with the armature. Based on the direction of the field winding connection, compound machines are further classified into two types, that is, cumulative and differential. Compound machines are further classified into two types, namely, long shunt compound machine, in which shunt field is connected in parallel with series combination of armature and series field winding. Short shunt compound machine, in which shunt field is connected in parallel with the armature by excluding the series field winding. This experiment is mainly concentrated to plot the characteristics of DC shunt motor. The representation of DC shunt motor is as shown in figure. In this, field winding is connected in parallel with the armature. The expression for the back EMF, EB, and the EMF equation is given by EB is equal to V minus the product of IA and RA. EB is equal to phi NPZ divided by 60A, where EB is back EMF, V is the supply voltage, IA is the armature current, RA is the armature resistance, phi is the flux, N is speed in RPM, P is the number of poles, Z is the number of armature conductors, and A is the number of parallel paths. The characteristics of DC shunt motor is as shown in figure. To conduct this experiment, we need DC motor setup, 1 voltmeter and 1 ammeter with suitable ranges, rheostat, mechanical load arrangement, digital tachometer, and connecting wires. This is the experimental setup of load test on DC shunt motor. While conducting this experiment, we should take the following precautions. Field rheostat should be kept in the minimum position. DC shunt motor should be started and stopped under no load condition. Discussion. After conducting this experiment, calculate the various parameters of DC shunt motor and plot its characteristics and also comment on the results. Applications. It is used in the centrifugal pump, machine tools, fans, reciprocating pumps, etc.
Hi students, let us have a discussion on load test on DC shunt motor. So the main objective of this laboratory experiment is to conduct the load test on DC shunt motor and to draw its performance characteristics. So before going to do this experiment, let us discuss some introduction about DC shunt motor. So basically the electrical engineering involves the analysis of energy transfer from electrical to mechanical or mechanical to electrical. This process is called as electromechanical energy conversion. So in general there are the two types of the DC machines. They are named as DC generator and DC motor. The construction point of view, whether it is a generator or motor, both are same. And in the case of the DC generator, the energy conversion from mechanical energy to electrical energy, whereas in the case of the DC motor, the energy conversion from electrical energy to the mechanical energy. And in the case of DC generator, the mechanical energy is supplied by the prime mover, and in the case of the DC motor, the electrical energy is supplied by the electrical supply. So here we are going to conduct the experiment on load test on DC shunt motor. So in general, the DC motors are classified into three types based on its connection of the field winding. They are named as DC shunt motor, DC series motor and DC compound motor. In the case of DC shunt motor, the field winding is connected in parallel with the armature, whereas in the case of the DC series motor, the field winding is connected in series with the armature. And in the case of the DC compound motor, as the name itself it indicates that it is the combination of both series and shunt. To conduct this experiment, we need 3-point starter. Why it is called as a 3-point starter means it consists of the three terminals. They are named as L, A, F. L is line, A is armature, F is field. And the purpose of 3-point starter is it is used to limit the starting current, and at the same time it is used to start the motor in a safe condition. This is the panel of DC compound motor. So it consists of supply terminals, that is positive and negative. Next DPST switch, that is double pole single throw switch. Next indicator. Next two fuses. Next 3-point starter terminals, that is L, A, F. Next it also consists of armature terminals A and AA, field terminals F and FF, and series field terminals S and SS. But here we are going to conduct the experiment on DC shunt motor, but this is a DC compound motor. As I already told, the DC compound motor, it is a combination of shunt and series field winding. So to do the experiment on DC shunt motor, so you have to exclude the connection of series field terminals, that is S and SS. So by excluding the series field connections, you have to make the connections. Then it becomes DC shunt motor. This is DC voltmeter to measure the voltage. So here you can use 0 to 500 or 0 to 300 volts range. This is the DC ammeter, and here you have to use 0 to 20 amperes, and this is used to measure the current. This is variable resistance. This is also called as a variable rheostat or field rheostat. It is connected to the field, and the variable rheostat mainly it consists of the three terminals. So among them, these two black terminals are used as the minimum terminals, and red terminal is used as the maximum terminal. And make sure that while doing this experiment, the field rheostat should be in the minimum resistance position. That means, suppose if we are using this black terminal as a minimum terminal, then this variac position, this knob should be in the same side. Otherwise, the motor runs at the dangerously high speed. This is DC rectifier unit. So usually in laboratories or household appliances we will get AC supply. So but here we are going to conduct the experiment on DC shunt motor. That means we need DC supply. So to convert that AC to DC, we are going to use DC rectifier unit. So it is a device, it converts AC signal into the DC. So it consists of the two DC meters. One is the voltmeter, another one is the ammeter. This is used to measure the voltage, and this is used to measure the current. And this is a variable knob. So by adjusting this knob, you can keep that voltage. These are the connecting wires to connect the meters. This is the DC motor setup. The nameplate details of the DC motors are: the rated current of the motor is 15 and 17 amperes, the rated speed of the motor is 1500 rpm, and the rated voltage of the motor is 230 volts. And this is the brake drum of the DC motor, and the output of the DC motor is the mechanical load. So that means we are going to apply the load in terms of the kgs, and here these two are the spring balances, and these are connected to the motor through this rope, and these are the adjustable knobs for the spring balance. By adjusting these two knobs, you have to apply the load. This is the digital tachometer, and it is used to measure the motor speed in rpm. Now let us start the connections as per the circuit diagram. Now let us take the voltmeter. Now connect this voltmeter across the motor terminals, that is positive and negative. So the positive of the voltmeter, it is connected to the positive of the motor terminal. Now negative of the voltmeter, it is connected to the negative of the motor terminal. And now keep the voltmeter in the horizontal position to avoid the error in the meter reading. So now you can see that the positive of the voltmeter, it is connected to the positive of the motor, the negative of the voltmeter, it is connected to the negative of the motor. Now let us take the ammeter. So this is the ammeter, and it consists of the two terminals, positive and negative. Now connect the positive of the ammeter to the supply terminal, that is positive, and negative end of the ammeter, it is connected to the 3-point starter terminal of L, that is called as a line. Now this ammeter, it is connected to the positive of the motor supply terminal, and negative is connected to the 3-point starter L. Now keep the ammeter in horizontal position. Now let us do the rheostat. Now, so first connect one connecting wire to the field of the motor starter. From here you have to give the connection to the minimum terminal of the rheostat. Now maximum end of the rheostat, that is red color, so you have to connect it to the motor field F. Now short armature terminals, that is motor armature terminal A and the 3-point starter armature terminal A. Now A and A are shorted. And next, short armature terminals and field terminals, that is AA and FF. So FF of the motor terminal, it is connected to the AA of the motor terminal, and again AA of the motor terminal connected it to negative of the motor supply terminal. With this, connections are finished. Now let us start the conduction of experiment. Now switch on the supply to conduct the experiment. Now this is the rectifier unit, the AC is converted to the DC. Now adjust the voltage knob to apply 220 volts. You can adjust this value on the voltmeter to get the 220 volts. Now switch on the DPST switch of the DC motor. Now start the motor with the help of the Now check the motor speed with the help of tachometer. So now it is showing 1447 rpm, so which is less than rated speed of the DC motor. Now adjust the motor speed to the rated rpm by varying the field rheostat. Now note down the readings under no load conditions. Now here the voltmeter it is showing 220 volts and ammeter it is showing 1.8 amperes under no load condition, and also note down the readings of spring balance, so that is S1 and S2. So under the low load condition the S1 it is showing 0 and S2 is also 0. Now apply the load by adjusting the brake drum and the rope arrangement. Now load is applied to the motor. Now here the S1 spring balance it is showing 0 and S2 it is oscillating between the 4 and 8. So you can take the average of these two. So that is nothing but S2 is equal to the 6. And here the load is applied in terms of the kgs. And for the applied load, note down the readings of voltmeter and ammeter. Now here the voltmeter it is showing 220 volts and the ammeter it is showing so almost 3.6 amperes. Note down the corresponding motor speed using the tachometer. Now note down the reading of motor speed using the digital tachometer. Now repeat the same procedure for different loads, and you should apply the load till the motor rated current, that is 17 amperes, and each and every load you have to note down the readings of voltmeter, ammeter and speed of the motor using tachometer, and also you have to note down the spring balance reading, that is S1 and S2 in terms of the kgs. With this experiment is completed. Now with the tabulated readings, so you have to calculate the efficiency by using the required formulas. After that you have to plot the graph between output versus torque, speed and efficiency.
At MSR UAS, we spark your imagination unlike any other.